I actually gave a talk. I've never had 4 screens or 2 microphones. So this is new for me. I gave a talk at PyData Carolinas 2 years ago, I think. I can't remember the title. It's on YouTube, but it's the substance of the talk was data scientists and really aspiring data scientists should be more proactive in sharing things online. I was very inspired as I was getting into data science in 2010, 2011 by seeing things that people were sharing online at the time who were in the early kind of data science movement. And I was like, oh, I'm doing similarly interesting things in grad school, just nobody knows about it. And so I started to try to be more proactive about sharing things online. And my number one technique for doing that is static websites that require no maintenance. So I do have a handful of them. Pythonplot.com, these are all linked from my website, is a tool that I've made to be useful to try to show people how you can make just simple exploratory plots in Python. And should I get a PhD.com, I did a number of years ago now, probably 5 years ago, I did interviews with 6 people in kind of the tech data science type space, some with PhDs, some without, about the questions I wish I had wrestled with before dropping out of 2 PhD programs prior to that. So those are free. You could go and read those, or you can buy the Kindle or EPUB version, and it's the only thing I've ever successfully monetized online, and I've made like probably $50. So yeah. Anyway, I try to do things that are going to be that I know would be helpful to me and try to make them available to be helpful for others, which actually is a good intro to this talk. So several caveats. One is I got moved into the Fairness in AI track because of scheduling. I need to leave this afternoon. I was supposed to be tomorrow. So if you're here hoping for a Fairness in AI talk, those are going to start after me, I guess. There's still time to leave. Secondly, I'm going to deviate a little bit from my proposal. I think there's another talk going on about Airflow right now. If you want a talk more about the nitty-gritty of Airflow, it sounded like that was the place to be. And I'm going to take this talk on a little bit more of a meta level as I try to reflect on some things I've wrestled with in my career in 6 years in data science. I'm going to see if I can make my laptop more visible because I'm taller than this podium. That's good. And with that, this is a talk about, I don't know if folks are familiar with Robert Chang, I think, from Twitter, wrote a blog post a few years ago about type A and type B data science, where type A is more kind of analysis type work, and type B is more like what now people are starting to call machine learning engineering type work, so putting machine learning models into production. And I think the profession of data science is in some degrees diverging, at least roles are diverging, although I think companies are failing to recognize that. So all that to say, this is a talk about my experience on type B data science, so putting machine learning models into products that are running into production and the challenges that are required to do that successfully. And I think a lot of companies in particular, non-data scientists, underestimate the challenges of doing that effectively, which is really ultimately limiting them. So that's the angle I'm going to take on this. And we'll discuss a little bit of practical things as well. So this is my new favorite way to describe myself is I use the handle TDHopper online, Twitter, and my website and various places. So I searched TDHopper on Google image search the other day, which I'd never done before. And I think actually the recommended Google image search recommends how you can make your topic more refined. The first recommendation is data science. Second is Dirichlet processes, which I have an open source package on non-parametric Dirichlet processes for topic models, which you can find and hopefully not use. Not because I don't want you to use it, because I just don't think you should use it. It's not that good. I'm an amateur photographer. I took several of these pictures and the thumbnails. I have projects on GitHub. I have a blog post about parallelizing Python for the extremely lazy, which is why that says parallelizing. And yeah, anyway, this is me. I have a bunch of diverse interests and things online. And again, hopefully those are helpful to you. I work for a company called Cylance. We make antivirus software. We're one of several kind of next generation antivirus software providers. So we do model-based detection of malicious software. Which brings me to what I in 2010, 2011 thought I might be doing as a data scientist, which was at the time reading Elements of Statistical Learning and imagining the hard part of data science was probably going to be choosing what kernel went into my support vector machines. And it turns out 6 years into my career, I don't think I've ever actually used a support vector machine. And my life is much less involved with the nitty-gritty of linear algebra and probability than I thought it would be. And it's much more in the nitty-gritty of engineering challenges around data science. Here's what my wife thinks I do. I work from home, so she just sees me sitting around various places in the house with the laptop. I showed her this slide and she said, I quote, "His hands should be typing." So that was her only caveat. CEOs, on the other hand, CEOs, companies that have machine learning products or antivirus companies that are all about using the term artificial intelligence in their advertising, just love to rave about their data scientists and the magic things that they do. They work wonders and turn terrible data into perfect predictions. I imagine if any of you are in similar companies, you've heard with horror the way sometimes your data science team is described by your CEO or your salespeople. And most of all, I never hear my CEO raving about how great I am at fixing pip problems and things like that. Well, my boss, he knows more about the day-to-day challenges that I face, but we have these bigger scale visions of what we want to do. We want to be shipping these machine learning models into production, and yet, when he comes to me for updates, it's, I spent the whole last week trying to figure out how to get our dependencies aligned in our versions of software and things like that. He doesn't, the moments where we actually provide our spending time refining our models and getting our models out the door is such a small part of the bigger project that we're working on. Of course, I want people on Twitter and all of you to think I spend all my time on the cutting edge of deep learning research, figuring out model architectures, doing the most amazing things with deep learning. I think there's a lot of temptation for data scientists to feel like that's where they need to be. And certainly there are lots of people doing big things with deep learning, but it's definitely, even if you're doing deep learning, it's maybe one of the easier parts of getting the deep learning is one of the easier parts of getting the deep learning model into a production system. I was turned down from a job a few years ago. Another one of the things I've shared online actually is all the companies I've interviewed at and gotten turned down for roles in the last 6 years, which I hope is helpful to people. Sometimes I'm known for being a data science luminary on Twitter, and it's easy to see people online, especially if you're getting into the industry. It's easy to see people and think they have all this great success and all these things. And I've been very fortunate in my career and my roles, but I still get turned down by jobs or for jobs. So anyway, all that to say, I got turned down from a job at a company that was a venture-funded deep learning company. They had some well-known deep learning professors starting this company. They were hiring all these former PhD students, expertise in deep learning, and deep reinforcement learning in particular. And I gave the pitch myself that, I understand enough of the deep learning, but then I'm also have this, I think, strong engineering skills and the ability to connect those things together to help get your products out the door. And I was turned down, and given the reason that I didn't know enough about deep learning and the nuances of it for the product, which I think, again, to my whole message of this talk, is a very short-sighted view. If you want to be a company that has machine learning models or deep learning models in production, and you are simply staffing up with people whose expertise is deep learning, you're missing the whole rest of the iceberg. I think icebergs are really cliche in business talks, which I think this is a little bit of a business talk, but that's the reality. Is there's so much that's so hard to do from an engineering side that can't be taken for granted. So what I actually do is read GitHub issues to figure out why I can't install certain pip dependencies for all kinds of projects. I spend a huge amount of my time working on problems like these through using open source libraries, using libraries that we have internally, and obviously not just pip problems, but these types of challenges that I think if you ask most practicing data scientists, unless they're in a company that is very mature or has really invested in these types of things, a lot of data scientists spend a huge amount of their time solving what are effectively pretty mundane technical challenges. So some examples of that. How do I install the Python dependencies for my exploratory data analysis? Simply making the decision in 2018 as to what ways in which you want to manage your Python dependencies is a challenge. There are now a number of different ways you can do that. You can use Conda, you can use pip, you can use requirements.txt files, you can use setup tools, you can use pip-bim. There are all these different options out there, and so even choosing is hard, and then once you've chosen, getting things to work the way you need is hard. Filter and it says extra, but should be extract features from data snapshots on S3, right? Many times where data scientists are hired into a company and they say, oh, they have all this data, and then it's just some sort of disorganized chaos on S3, and then it's up to you to figure out how to get that data. And maybe you're going to have to figure out how to spin up an AWS Spot instance with enough RAM to load that data into pandas. You maybe are just left to that entirely on your own. How to get your instance, how to make sure it's secure, how to get all your dependencies installed so that you can run Python. Maybe then you have to jump through some hoops to get Python 3 onto the AWS Linux AMI, all these different challenges. And then maybe you want to configure your EC2 instance and your VPN so that you can access your Jupyter server or your Jupyter Lab server from your local computer, right? The Jupyter runs in the browser. You're trying to run this your code on a remote machine that doesn't have a GUI interface. How do you get that locally? We've probably all done some crazy port forwarding or SSH tunneling at times to make something like this work. How do you translate your scikit results into a form that can be re-implemented into production? Very often in companies, data scientists come in, they're using Python, maybe they're using other comparable things like R or whatever. Your engineers who are working on the product are using some completely different stack. They're using maybe Java or Scala, JVM-based tools, they're using Go or whatever. And then you have this disconnect. Okay, I'm producing these models in scikit-learn. How do I get these to run into my production system? So you do crazy things to extract your results out of scikit and then help your engineers re-implement those into the production model. How do I extract code and from random scripts and notebooks and turn it into a Python package? Again, this is not totally unique to Python, but using Python in a maintainable, shareable, clear way where you don't just have kind of folders and folders full of scripts and notebooks that only you know how to run and understand, but instead have tools that are generalized and able to be run on multiple systems, and using Python in the way that has become idiomatic in the sense of you hire someone else who knows something about Python and they're going to be able to come in and understand it and reuse it. It's a hard thing, and we take for granted that that's an important skill for a data scientist in 2018. Maybe you want to write shell scripts so that you can bootstrap your EC2 machine to reproduce your analysis, so that every time you need to do this analysis where you have to spin up a machine that's big enough to do it, you don't have to go in and remember some complex chain of apt-get install commands to get all of these dependencies. So you start to recognize you need to standardize that and you put that into a shell script. Maybe after all this, you decide to move your Python environments inside Docker containers so that you don't have some of the frustrations of getting your dependencies installed on systems with slightly different configurations or missing different compiled libraries. Maybe after you do that, you want to figure out how to share your Docker images with the rest of the team so that you're actually using Docker in a way that's valuable instead of just rebuilding your images every time, which is sort of defeating the purpose. I think many of us have tried to build some kind of dashboard to monitor the performance of our model predictions in production. And we've jumped through various hoops and adapted tools to make them work for our needs. A challenge that many face, I think, and companies can easily leave unsolved is how do data scientists schedule tasks to run on a schedule repeatedly and in a way that data scientists can deploy their own tasks and have insight into them? How do data scientists do whatever people do with Kubernetes? And worst of all, last but not least, how do we configure AWS permissions, right? The security, and this is not just because I work for a security company, but security is one of the most important aspects of computing today, as we just hear of company after company that are having data breaches. And sometimes those data breaches are their S3 buckets were public, and someone has, attackers essentially write scrapers to just try to find public S3 buckets and then see if there's data in them that could be valuable. And many of us, many companies, many data scientists are using S3 or similar tools on the Google Cloud, wherever, to store their data, and they're trying to make this work in a distributed fashion where they can access it from different systems, different people in the company can access it. And the challenges around configuring that correctly are really hard. They probably shouldn't fall on data scientists, but how often do they do that? So I'm trying to understand, this talk is really an outworking of me trying to understand why we have this lack of alignment between talking about data scientists as these researchers who understand machine learning, they understand math and statistics and probability, they understand science, the scientific method, all these different kinds of things. And yet, in my experience talking to data scientists day to day, very few of them actually spend all that much time working on the problems around that perceived, not even perceived expertise, but this expertise they probably actually have. But their life day to day is kind of these more mundane engineering challenges. Does this resonate? Does anyone experience this in your own work? And I'll take those nods as quiet amens. I talk to a lot of people who face this same thing, and I am attempting to. Well, I've spent time in my own career trying to communicate this reality internally in companies and try to, not in an attempt to get out of work, but in an attempt to get company leadership to recognize the challenges of data science and ultimately the challenges of running machine learning models in production are much harder than they would appear. So the next few slides are something I've wrestled over probably more than any other talk, and I'm still not totally satisfied with it. So I would love to continue this conversation with people if you have insight into this. This is my attempt at trying to understand why this is the situation that we have. And hopefully, I gave this talk to some of my colleagues on Thursday, and afterwards a very helpful colleague said, so what are you hoping people are going to take away from this talk? Which really wasn't clear. And I've tried to clarify that, but my takeaway for you, assuming most of you are data scientists or aspiring data scientists or something in that realm, and not vice presidents or the people that this talk is kind of directed to, my takeaway is twofold. One is I would like to continue to have this discussion as this conversation as to why we have these problems that we have. And secondly, to try to give us all a better framework for articulating the challenges that we have and getting companies to commit to solving these challenges so that we can do effective data science work. So point one, I think, is that data scientists solve problems. This is, for many of us, this is one of our greatest skills. I think as I look back on my own career, I've been fortunate with great education and great opportunities. But I think one of the main things I contribute to companies is that I'm just very tenacious, and I just will keep attacking a problem until I can figure out how to solve it. I think for many data scientists went to grad school, particularly those who are in PhD programs. This is one of the things that helped them make it through a PhD program, and where they had challenges and frustrations with poor documentation, detached advisors, and limited support for their work, and they were just forced to go out there, figure out how to solve the problems that needed to be solved, and power through and get their research done. And many of us bring that kind of mindset into our companies. And I think because data scientists as a role are technical in that they are using computers and programming to solve their problems, and that because they're problem solvers, a temptation can become, and this maybe is truer in smaller companies rather than huge companies, I don't know, but the temptation can become for senior leadership to leave them to solve all their technical problems because they're capable of doing it. So therefore, they should be doing it. I think the risk here is that sometimes we, or at least I, can invent solutions that are really Rube Goldberg machines. And they get the job done. Maybe they're even cool to watch. But they can be way overly complicated. And they can result in having tons of components that need constant maintenance that are things that we shouldn't be spending our times on. And they can be opaque, brittle, unmaintainable, idiosyncratic solutions to our problems. If you don't resonate with this, I'm happy for you. I think there's a temptation for, as I've already saying, VPs of engineering and others who are in similar types of leadership roles. They leave their data scientists to go solve their own problems often, and yet at the same time, they don't want their data scientists being engineers. And so as the data scientists go out solving problems, if their solutions start to sound like engineering solutions, they might get the brakes put on them that, oh no, you're not engineers. You shouldn't be building this whole architecture. You shouldn't be building this engineering platform to solve your problem. You're not. We should leave that to the engineers. And yet they don't. My wife is calling me. And they don't provide the engineering resources needed to solve the problems. And so the result is data scientists are left solving problems in a kind of under the radar way that ends up being a very nearsighted solution from an engineering perspective. And they're building technical debt. They're building problems that are only going to come down the road because they're not allowed to, and maybe sometimes aren't even capable of, for no fault of their own, building the engineering solution that their data science problem needs. And so we can end up with these production models being shipped, and yet they're a house built on sand, where we have a model in production that for all kinds of reasons we are now unable to retrain, or maybe we're really unable to monitor because we haven't built out the monitoring tools. We're unable to redeploy because we had this manual, massive deployment process that was seen as our data science work because we couldn't go and build an engineering solution for this problem that would make the deployments work better. And I think this can be reflected in what I was already describing about being turned down for this job, where data science teams or groups are overrepresented in a way by researchers and machine learning experts, and underrepresented in terms of the needs by people who can solve these engineering problems. Great data science, I believe, needs great engineering solutions. It's tempting in companies, the same problem they can think of, well, machine learning models just need some data, so we just need to give our machine learning experts, our data scientists, access to data, and then build something like a service that can make predictions. So it's this very simple thing. They get the data, no thought given to, do they have labels on their data that they can train models with? And then they just need something that can make predictions without thinking about all kinds of engineering challenges on both the micro and the macro level. So micro level, we can think about issues around, can you install your Python dependencies to do your analysis? And then macro level, thinking more about like architecture and larger scale problems. If you haven't read this problem from Google, or this paper from Google, I published a few years ago now, a paper called Machine Learning, the High Interest Credit Card of Technical Debt. It's freely available from Google's website. Well, the first two sentences of the abstract really summarize in a lot of ways the points I'm trying to make. Machine learning offers a fantastically powerful toolkit for building complex systems quickly. This paper argues that it is dangerous to think of these quick wins as coming for free. Machine learning, the paper argues, can introduce all kinds of technical debt into your system that can, in the worst case, make you have some kind of production system that's making predictions that you can't even touch or improve over time. They enumerate a number of examples from the hidden feedback loops you can introduce in systems to where you can't retrain your model because you have feedback loops from the effects of the previous model. Unstable dependencies in your data so that you can't reliably get the data that you need. Fixed thresholds and dynamic systems is one of the sections where you have these hard-coded values that don't adapt as the situation changes. I think this is a brief paper and it doesn't really outline all the solutions, but it raises a lot of the concerns that can go on here. And I think the point I'm trying to add to it is that often the solution to these science type problems are engineering solutions. They're not, it's not that we need more math, we just need better engineered solutions. And engineered solutions that understand and can support the math and modeling problems. Also in 2018, and this has been true for a long time, but is really becoming acknowledged over the last 10 years, particularly as we've moved to cloud-based architectures, that great engineering needs infrastructure and operations. And that becomes a huge part of the engineering challenges today. When you think about how much time you might spend writing code versus how much time you spend configuring AWS and the like. This whole movement, you've probably heard the term DevOps. This has been a movement over the last 10 years, and you may not understand, I think there's often misunderstandings of what that term means. And it doesn't have a single definition, which is a challenge. It doesn't really necessarily even have a single history, but generally it's regarded, and this is a quote from Atlassian's website, I think it's as good as any. DevOps is a set of practices that automates the processes between software development and IT teams in order that they can build, test, and release software faster and more reliably. The concept of DevOps is focused on building a culture of collaboration between teams that historically functioned in relative silos. The promised benefits include increased trust, faster software releases, ability to solve critical issues quickly, and better manage unplanned work. As a theory, the idea of DevOps was for developers and operations to come together and work together in a way that allows software to be released more quickly, more things to be automated, things to be captured in code versus just in people's heads or in documentation, ability for engineers to make faster and more frequent, more frequent updates, automating deploys so that you don't have people knowing some sort of complex manual way to deploy something, and also a security focus on your infrastructure and operations. And when that works well, from a software perspective, you move the things into automation that can be automated as much as possible, and those things can be built quickly, and then you can focus on the product, the problem that you're trying to solve, and not just spinning your wheels all the time with these operational challenges. Yet the reality is, if you have a DevOps team, many times DevOps teams can hinder DevOps practice. So companies are renaming or naming their operations type team DevOps, but they're not actually doing DevOps. You still have these silos. You don't have these teams working together. And so your DevOps can become a blocker to moving quickly, where you maybe make requests and they never get fulfilled, or they just enter a queue and they take weeks before the thing happens that you need. So then you have this situation where on the road to success there are no shortcuts, and yet you try to take a shortcut and you don't get success. And as so DevOps is this idea of developers and operations coming together. I think this is a mindset and a principle, a philosophy that we need in data science, and yet adding machine learning systems into this whole picture simply makes this whole thing more complicated. It becomes an even harder problem to solve. And just allowing all of the responsibilities to fall on data scientists, I think, is companies often shooting themselves in the foot in being successful with data science. This is a tweet from a couple months ago. Pete Skammeroch was at LinkedIn in kind of the heyday of LinkedIn data science, and has been a leader in the data science community over the last 10 years. And he tweeted a couple months ago, as a rule of thumb, you can expect the transition of your enterprise company to machine learning will be about 100 times harder than your transition to mobile. And he didn't really go into great depth explaining this. I think he was thinking through this and planning a talk of his own. But I think companies really fail to miss this point. And I've tried to outline some ways in which that's happened. So maybe what we need is data side DevOps, where we both have data science and developers working together, and developers and operations working together, and operations and data science working together. We, instead of just two aspects of developers and operations working together, we need this integration across all these teams, which is a hard and expensive prospect for companies. And maybe people have already realized this. We see an emerging role of machine learning engineer who are more focused on these types of problems and who are supported by their companies in solving these problems. I suspect many data scientists who are in roles like mine are fulfilling a role that would be more better called machine learning engineer. And yet my perception is companies have been, all these things are changing so fast. Data science just appeared, but maybe it needs to already be divided in a way that makes more sense for the success of the company. But at the end of the day, what we need is leadership of companies to stop thinking that there's this magic unicorn role of data scientists who can fulfill all these tasks and execute them in an effective way. Again, great machine learning is in products is going to require great engineering and great operations. And without that foundation built and that working together through the life cycle of a product, I think companies are going to fail to successfully put machine learning models into production. I will break. I think the session ends in 4 minutes. Is that right? All right. So if there are any quick questions, you can take that, but I don't want to hold you up from getting to later talks. All right. Thank you all very much.